OK. Procedures for testing the FC automation drive B enclosure units. By the end of this module, you will get a basic understanding on the various procedures of static test conducted on rectifier, IGBT, dynamic test conducted on output IGBT. In this module, we shall learn about various procedures for testing the FC automation drive B enclosure. Before starting this module, let me give you a quick note. It is to be known that, before power up the fault unit, it is always recommended to carry out a static test. The static test checks the power components like rectifier and IGBT, and avoid destruction by power up if they are short circuit. The static test point out which component, rectifier, and or IGBT, are defect. The B enclosure has total of 6 diodes. In the FC automation drive B enclosure, the rectifier and IGBT are integrated in one power card. If rectifier or IGBT fail, the complete power card have to be exchanged. Never disconnect the input cabling to the FC automation drive with the power applied, due to danger of severe injury or death. Take all the necessary safety precautions for system startup prior to applying power to the FC automation drive. After repair and assembling, the static test is recommended to be sure that the assembling is well done. Only after conducting these tests, and the unit pass the static test, the drive can be connected to mains and power up. Now, let's proceed with the module. In this section, we are going to learn the various testing procedures conducted for FC automation drive. For static test, all tests should be made with the meter capable of testing diodes. For dynamic test, and to get a good reading, use a true RMS meter. Before making any checks, disconnect all input, motor, and brake resistor connections. Testing of FC automation drive is divided into static test, dynamic test. First, let's see how static tests are performed. Static tests are performed without the need for power applied to the FC automation drive. Most of the FC automation drive power problems can be diagnosed simply by performing these tests. Never disconnect the input cabling to the FC automation drive with the power applied, due to danger of severe injury or death. Take all the necessary safety precautions for system startup prior to applying power to the FC automation drive. The static test can be performed with little or no disassembly of equipment required. The purpose of performing static tests is to check for shorted power components. Simple ohmmeter checks are made to check the components under short circuit. It should be kept in mind that ohmmeter capable of testing diodes is to be used. Now, let's see the procedure for conducting the static test on rectifier, IGBT. First, let's see how to perform a static test on a rectifier. The purpose of making tests on the rectifier is to rule out failures in this device, either shorted or open diodes. Failure of the rectifier module will usually result in blown input line fuses. Now, let's see the procedure to conduct the static test on rectifier in order to test the first set of rectifier diodes. Connect the negative terminal of the multimeter lead to the positive DC bus. Connect the positive terminal of the multimeter lead to the input terminal L1, L2, L3. In turn, the multimeter should show the diode drop of around 0.4 volt on the 3 terminals. Now, reverse the meter leads. That is, connect the positive terminal of the meter lead to the positive DC bus. Connect the negative terminal of the meter lead to the input terminals, L1, L2, L3. In turn, the multimeter should show diode open. Locations for UDC plus and UDC minus is opposite for the B1 unit. Now, repeat the procedure by connecting to the negative DC bus in order to test the second set of rectifier diodes. Connect the positive terminal of the multimeter lead to the negative DC bus. Connect the negative terminal of the multimeter lead to the input terminal, L1, L2, L3. In turn, the multimeter should show the diode drop of around 0.4 volt on the 3 terminals. Now, reverse the meter leads. That is, connect the negative terminal of the multimeter lead to the negative DC bus. Connect the positive terminal of the multimeter lead to the input terminal, L1, L2, L3. In turn, the multimeter should show diode open. A diode drop reading will vary depending on the model of ohmmeter. Whatever the ohmmeter displays us, a typical forward bias diode is defined as a diode drop. In these procedures,